Hey, Nathan here. Welcome back to a new series covering MonoGame. The previous 3 tutorials covered the basics of MonoGame, and I wanted to keep that contained to those 3, just the very basic concepts. This is an advanced techniques, advanced topics series that will cover. This will pretty much be the rest of the MonoGame stuff that we discuss. Every other tutorial that covers MonoGame will be part of this series, so this series will be pretty large. I am using Visual Studio 2015 for this series. That was part of the reason why I waited for a while to get a new series going. I finished the DirectX 9 basics and MonoGame basics, so I had no series going on. And I did not want to change Visual Studio in the middle like I did before with the Visual Studio 2013 release. So I wanted to wait until I was between series to update to Visual Studio 2015. I did not want to start a series and then 2 episodes or 3 episodes later you'll have to upgrade to 2015 if you want to follow my samples. That being said, you can download my samples and then use the CS files, just use the code and then make your own solution in a lower Visual Studio. That should work fine. I'm using the professional version of Visual Studio. In the US, at least where I am, you can buy the perpetual license of the professional version of Visual Studio 2015. You don't need to buy it with MSDN right now, and you do not need to buy it with the monthly subscription. They have now released the perpetual license in the Microsoft Store. They said that it would be available to more markets going through October, so if you don't have that yet and you want it, just keep on checking the store and hopefully it will show up for you soon. But right as soon as that came out, I jumped on top of it to get the perpetual license of the professional version. Just in case if they discontinue it at some point and I need more than the community edition. That's the reason why I got it. Okay. So this tutorial, or this video for the advanced series is going to be a introduction and preparation for the series. Let me bring up OneNote. Or actually, I'll just bring up my list of tutorials since OneNote has been a little out of date right now. So I've been working on creating a whole bunch of samples, and most of these are complete and ready to be made into tutorials. These are the advanced topics that I will discuss, and they're in this file. This is the order up until tutorial 12. And then after that, we will discuss, skeletal animation and more topics after that. I moved some things around. If you watched my August update, I mentioned a few tutorials, and you might notice the order is different than the way I had it in the video. I decided to rearrange some things to make it more flow nicely. And I moved the rotated rectangle to the end. That will probably be pushed down to a later tutorial. So up until tutorial 12, from this is the order. Tutorial 12 might change to something else, but the 1 through 11, up until tutorial 12, this is the order and when the tutorials will appear. So if you're really interested in like vector reflection, for example, that will be tutorial 9, and that will not change. That will be tutorial 9, so you know what tutorial number you need to look out for. And I will label it vector reflection as well. So this is the order. And like I said before, my code will be Visual Studio 2015. If you're running a previous version, you can just use the source code, the .cs files, and just manually create your solution that way. So that is the introduction to the series. Now what I also want to do is do a preparation work for the series. Get the foundation going, and then that way we can jump up and get going on the tutorials. Some of these tutorials will be very short. Hopefully around 5 minutes. Other tutorials will be longer. Okay, so let's create a new project here. And let's create a MonoGame project and a MonoGame Windows project. I'm going to call this MonoGame Advanced Preparation. So MonoGame Advanced Preparation. Alright, once that loads, let's open up the game1.cs file and let's take a quick look. So this is the game1.cs file that is generated whenever we create a new project with MonoGame. If you haven't seen any of my previous videos, or recently I got ReSharper as well, and Visual Studio 2015 Professional has the code lens feature, which is really nice. It gives you how many references that a certain function or method has. That's one of the really cool features that I wanted in the Visual Studio version that was not in the Community Edition. So it's nice seeing how many references a function has, and also ReSharper lowers the opacity if it's not being used. Or there's pretty much no point in using it. We have the initialize method here, and all it does is call base.initialize, so there's no point for us to have it in there. And also, if nothing's being referenced, you will also have the opportunity to remove it if you want to. Okay, there's a couple classes I want to build before we go into tutorial 1. I want to build a sprite class. So let's right-click MonoGame Advanced Preparation. Let's go to Add Class. That's outside of your screen, but if you go to Add Class there, let me move this over here. Right-click that, go to Add Class. So we're going to add a class, and I'm going to call this Sprite. And let me move the window back here. And let me slide out the Solution Explorer a little bit so we get more of a window here. Okay, so the class Sprite, let's make that a public class. So this is going to handle everything that our sprite needs. It's going to have a rectangle, a texture, a position, a velocity, and what color the texture needs to be. Alright, so let's go ahead and start building this. We're going to make a private color attribute, or color field. And we're going to use the Microsoft.XNA framework, so I'm going to add that to the using statement above. The good thing about ReSharper is it will automatically add stuff. If you copy and paste code and you need to have a whole bunch of using statements, you can just hit Alt-Enter and it will add them all to the list. So I'm going to make a private field here. Now the good thing about ReSharper is you can have a consistent rule set up to how you want to name your private fields, public fields, properties, methods, and so on and so on. I've gotten used, by default, it likes to have underscore and then all lowercase, a lowercase camel case for the fields. I used to hate that style, now I've gotten really used to it. So that's why I'm putting underscore on private fields now. You can remove that if you were like me in the past where you didn't really like that, just feel free to name them however you like. Private vector 2 velocity. So I'm going to make a private velocity vector 2, private vector 2 position. Now we need a rectangle and texture. Rectangle and texture is a texture 2D. And you saw there, I didn't add the using statement, but ReSharper automatically took care of that. So if you don't have that, just add the using Microsoft.xna.framework.graphics at the top. Okay. So that's it for the private fields. Now I'm going to make the constructor. So let's go ahead and create the constructor. Position, speed, and angle. So all we need here is position. So position, float, speed. That's going to be an optional parameter. So for optional parameters, you put equals and then the default value. And I'll explain that after I finish the next one. Float angle is equal to 0. These are optional. With this constructor, we can call sprite s is equal to new sprite, open parentheses, new vector 2, 100, 200, closing parentheses, closing parentheses. That's it. So we can call sprite s is equal to new sprite, new vector 2, 100, 200. We can just do that. Then it will make speed and angle default to 0. If we want to provide a different speed, we can do 12 here, and that will only change angle to 0. If we want to have our own specific angle, we can do that too. Like that. Those are all valid. I'm actually going to remove this for now. So those are optional parameters. We do not have to manually specify them. Okay. Now let's go into the constructor and let's set velocity is equal to new vector 2 float speed times math.cosine angle. Alright, that is the x component. The y component is similar. Speed times math.sine angle. If you're not sure what that means, check out my Game Math Tutorial 1 where I discuss vectors. I'm going to set the texture to null. We didn't pass the texture in. I'm going to set the color to color.white. So that is the constructor. Now, I'm going to have some pretty interesting properties going on. The newest C# allows you to use something called expression bodied properties. And what that means is if you have a property that's only a getter, a property can use get or set or both. If a property is only a getter, you can use this new technique and have expression bodied properties. So this is actually going to be a protected value, since it's going to be only used internally for this class, and I'm actually going to drive this class in this video. This is going to be the texture, and it's only going to be used internally when we want to draw the sprite. we don't need to have direct access to the texture. So protected texture 2D texture equals greater than, and then the value you want to return. That is a expression bodied property. Now I can convert that to an auto property. I'm going to ignore that suggestion. Okay. Public vector 2 position. That's going to be public accessible. Remember, these are private fields. I only want to get the position, not set it. Same thing with rectangle. So that is just a public getter for the rectangle field. Public bool collided. Get private set. Alright, so some of these things can get a little irritating if you have used ReSharper or are thinking about getting it. Some of these things are a little irritating as you are building a class from scratch. So just ignore some of these suggestions and come back to it later. That's my best advice. So this is going to be the basis for all of our sprites in this series. We can derive it, and we will actually derive it in a specific class in this video. These properties and these public and protected accessible properties as well. Texture is set to null on the constructor, so we need to have a way to get the texture on the sprite. And I chose to implement a load content function. So public accessible void load content. Pass it the content manager. Be sure to add using Microsoft.xna.framework.content. Graphics device. And string asset name. So we pass in those three things, and then we can get our texture from that. Texture is equal to content.load. It's a texture 2D asset name. And now I'm going to call a method on content loaded. I'm going to pass in the content and graphics device. Now that method does not exist, so let's go ahead and create that. Protected virtual void on content loaded. Why are we doing this? Content manager, content. Let's finish building the method here. Why are we doing this? A good thing to keep in mind, and I've been guilty about this in the past, especially if you look at my tower defense sample. A good thing to keep in mind, and this sometimes can be difficult, a method should only do one thing. Now, sometimes that's a little confusing. If you want to do several things when there's a button press, that's fine, but you need to break that into separate methods. So that button press method can do multiple things, but each part should be its own method. So we are doing this load content is doing one thing. It's loading the content. Then we are doing something else after our content is loaded. It's calling the on content loaded. So that on content loaded is doing its own thing as well. If you take a step back, and you can argue that this is doing two things. It's loading the texture and it's calling a function. but that's fine. What we want to do is separate the methods or functions, whatever word you want to use. I keep going back and forth because I've been doing C++ a lot. You want to have those do one thing, and they can call other methods that do one thing only. So that is what we are doing. Once you have the texture, then we can build our rectangle. So that's what we need to do here. We need to build our rectangle after we get the texture. We do not want to have that done in the load content. We want the load content method to only load the content. And this, you can make this an event driven, or you can just call the method, which is virtual, so we can override it if we want to. But once the content is loaded, we can do more stuff, like update our rectangle. So that is what we need to do here. Update rectangle. Alright, so let's make that method as well. Okay, so private. Private void update rectangle. We are doing this in a method because we need to update the rectangle whenever the position changes and whenever our texture changes. Underscore rectangle is equal to new rectangle. We need to cast all these as int for the position values. Because rectangles only operate in integer values, and a vector 2 is float based. I can make that underscore position. Alright, so a rectangle is x, comma y, comma width, comma height. So that is why we needed the position and the texture in order to build the rectangle. That is why we could not create it in the constructor. It's because we did not have the texture. So we had to rely on the load content to initialize our rectangle, or at least update it. So if we load the content with one texture and then we want to load the content with a different texture, we still want to update the rectangle because the texture changed. If we have a load method, we should probably have an unload. Now I'm going to make that a virtual. And just dispose the texture. A good thing to keep in mind, let me go to definition here. I'm sorry. Let me go to definition on the class. A good thing to keep in mind, and I'm going to go to the texture too. I'm going to go to the graphic resource. Anything that implements iDisposable, you want to call dispose. So texture 2D derives from texture, which derives from graphics resources, which implements iDisposable. So you want to call dispose on the texture, which is what we do here. So anything that implements iDisposable, you need to call dispose on that. So when we call unload on the sprite, it will dispose the texture. Alright, so that is the unload. Now let's work on the update. Update has game time which we use to smoothly move our sprite because we use the physics formula for updating the sprite. So underscore position is equal to plus equals underscore velocity times, we need to cast this as a float, game time dot elapsed game time dot total seconds. This is a physics formula to update position. Position plus velocity times time updates our position value. So velocity times time, total seconds, and I need to cast that as a float because that is a double. Take that times the velocity, and that increases our position. Whenever position changes, we need to update our rectangle. Whenever our texture changes, we need to update our rectangle. So that is why I created a method here. Another thing to keep in mind, and I've been guilty about this in the past as well, code repetition. You should not do code repetition unless you absolutely need to. For example, you might say, well, you say don't do code repetition, but here you are, or you're calling a method twice. That's what I mean by if you need to. You don't want to call this, you don't want to do this twice. Because what if you need to change the way that you update your rectangle? So we call the method twice, and that way all the logic required to update rectangle is in one place. If you need to change the way that you update the rectangle, you only have to do it once. So code repetition is not very good unless you absolutely need to, like calling a method twice. That was update. Now let's look at the draw method. Public virtual void draw needs the sprite batch and game time. And the sprite batch, we'll just call it sprite batch. Okay, there's two things we can assume here. I'm making the assumption that we are between the begin and end calls, that we have started a sprite batch cycle. So we do not have to call begin. I'm going to assume that begin has been called. And we can add that to the summary of our method, just to give people who use it a warning. So I'm going to draw using the texture, position, and color. Okay, so that is it for that class for now. Like I said, I'm going to derive this right now, and I'm going to add a new class called Debug Sprite. This will show the bounds and then the initial location of the sprite without any transforms that we'll do later or anything like that. It will just show us, give us debug information, where the bounds are in the sprite, and just anything else we need. It's going to be a public debug sprite, and it's going to derive from sprite. Okay, now, debug sprite. It's going to have a rectangle color. Oop, I need to add the using statement. Rectangle color, and it is going to have the rectangle texture. let's add. I mistyped it, that's why. Okay. So we have color and texture for the rectangle. Now let's create the constructor. Alright, so the debug sprite is going to have a position, and it's going to have the color, rectangle color as the second parameter, and then speed, and then angle. Then we call base and only provide position, speed, and angle. So the only thing that we need to do inside of this constructor is set rectangle color is equal to color, which we pass in. Okay, now I'm going to override the onContentLoaded method. So override the onContentLoaded method like I did here. Protected override void onContentLoaded, content manager content, graphics device, and be sure to call base.onloadContent. Color, opening and closing square bracket, we're going to do an array here. Colors is equal to new color, and we need to have the texture.width times texture.height. So what I'm doing here is creating a new array that will completely encase the texture's width and height. Now I'm going to manually set the corner colors to the rectangle color here. And what we need to do there is colors index 0. Colors at index 0 refers to the top left corner of the texture. The very first color in the texture is the top left pixel of the texture. So we're going to set that is equal to the rectangle color. The next thing we need to do is look at the top right pixel of the texture, and that is colors at index texture dot width -1 is equal to underscore rectangle color. Now the bottom left pixel of the texture is colors, open bracket, and then we're going to use at index, open parentheses, texture dot width times texture dot height minus texture dot width. Texture dot width times texture dot height gives us our last pixel, which is the bottom right of our texture. So we need to subtract the width to give us the bottom left. Oop, not that, rectangle color. Now for the bottom right. Colors at index rectangle.width times rectangle.height. Now I'm going to subtract 1 from that. I'm subtracting 1 from that because index in C# are starting at 0. So that would be an index out of bounds. If I subtract it by 1, then it would be the last index in the colors array. Underscore rectangle texture is equal to new texture 2D. Now you will see why I passed in the graphics device here. Graphics device, texture.width, texture.height. Whenever you create your own texture 2D, you need to provide the graphics device. So that is why I needed to pass it in the onContentLoaded. Underscore rectangle texture dot set data colors. Once that texture is created, we can set the color data based on our colors array. Now all we need to do is call base.onContentLoaded. Now I'm going to override the draw. I'm going to override the draw method. Now I'm going to call sprite batch dot draw underscore rectangle texture comma null comma rectangle comma null comma null comma 0 comma null comma color dot white. Okay, this is just a very basic expanded draw call that we want to use the rectangle, and then that 0 there is the rotation, which will be 0. So we don't want to rotate our debug sprite, we want to have it at the rectangle of our sprite. We want to use the rectangle texture instead of our sprite's texture. And color.white, because we set the rectangle's color here. And then whenever we draw, if you use color.white, it draws as you intended it to. It has no tints or anything. So that is the debug sprite. And that should be it for right now. So if we press F6 or go to build and rebuild, we have no errors. So this is the preparation. We will use the debug sprite to give us an indication on where things are. For example, let me bring up my transformed rectangular collision detection here. Let me bring up that solution and I'll run it, and I'll show you what the debug sprite shows. So the debug sprite is what you see, those 4 dots around the surrounding arrow. The debug sprite also shows that dark, slightly visible arrow that continuously points to the right. So that is the debug sprite, the initial position without any transforms, without any rotations, without any scaling, without any position changes. That is where the default sprite is supposed to be located. And then the 4 dots around the corner, that is for the bounds of the rectangle. Those 4 dots is what we just built here. Top left, top right, bottom left, and bottom right. So that is what the debug sprite shows. In your actual game, you won't actually use a debug sprite in your final version of your game. You might use something like that in your alpha phase or as you're programming it, but when you finally release your game, you won't use a debug sprite. Okay, next video we will discuss rectangular collision detection. We will build on top of these, and then tutorial after tutorial we will build upon the last tutorial. So the tutorial 1 will build on top of the preparation that we just did. And then going forward, we'll just keep on building on top of it and building on top of it We might delete a few methods here and there, and then add some similar methods in the future as we go. But we will continuously build on top of these. I will provide this in the download. This will be labeled Tutorial 0, Introduction and Preparation. I hope you will enjoy this series. It will be ongoing for a very long time. And do not worry if you're not sure what this means. I will release a dedicated C# 6.0 and just C# in general video series as well. So I hope to see you next time for rectangular collision detection. Thanks.